Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper. We call it paper 2. And for this purpose, we have selected October-November 2023 Physics 5054 2 paper. This paper 2 belongs from the zone 2. So in this paper, the time allowed to attempt this paper is 1 hour 45 minutes. And the total marks for this paper are 80 marks. And the special thing about this paper is that the value of the acceleration due to the free fall, we will take it as 9.8 meter per second square. In this video, I'm going to present to you the solution of this paper to the best of my knowledge and my ability. I hope you can write better answers than the answers which I will be giving. So let's start today's paper. The question number 1 is coming up on your screen. He says, velocity is a vector quantity, but speed is a scalar quantity. A part is, state how a vector quantity differs from a scalar quantity. So the basic difference between a vector quantity is that it has magnitude and direction, whereas the scalar quantities have only magnitude. They don't have direction. So the basic difference between vector and the scalar is of the direction. So my answer is that vector quantity has direction, while scalar quantities have only magnitude. So this is my answer. So let's look at the marking scheme. You can see the first part. This is my answer. Question number 1, and it's B part, and you can see they say, the B part says, underline all the vector quantities in the list. So the first one, acceleration. Acceleration is a vector quantity. And distance is a scalar quantity. Energy is a scalar quantity. Mass is a scalar quantity. Momentum. Momentum is a vector quantity. Temperature is a scalar quantity. So I hope you understand this. Okay. Now we are going to the question number 1, it's C part. He says figure 1.1 shows a passenger running across a large ship at right angles to the direction in which the ship is moving. So here we have a passenger which is running towards the north, due north, at a speed of 2.4 meter per second. And the ship is going due east at a speed of 6.8 meter per second. The passenger runs across the ship at 2.4 meter per second due north. The large ship is traveling due east at 6.8 meter per second. Determine either graphically or by calculation. So we have a choice here. We can do this. We can find the resultant by using the graphical method, or we can do the calculation. Because both the vectors, they are making 90-degree angle, whose resultant we want to find out. The resultant velocity of the passenger. Give the direction in which the passenger is moving relative to due north. So show your answer in the, show how the answer is obtained. We have to tell what is the velocity, and we also have to tell what is the direction of that resultant velocity with respect to the north. So here we have, two vectors. This vector is 2.4 meter per second due north, and the other vector is 6.8 meter per second due east. So I will try both the methods and I will try to explain. So here we have the first method. In the first method, you see I have written, this is the calculation, okay? So how you get this answer by calculation? Because both the vectors are making 90-degree angle. So we can very easily find out their resultant. So we are going by calculation. So this vector is 2.4 meter per second due north, and this vector is 6.8 meter per second due east. I have written here the triangular method. Here you have 90-degree angle between them, because this is in the north, this is in the east. So it's a right angle triangle. And if you join the tail of the first vector with the head of the last vector, that will be your resultant. And this is the hypotenuse of this right angle triangle. So you can find out by applying the Pythagoras theorem. So we will apply the Pythagoras theorem, and 6.8 square plus 2.4 square, and take square root of it. And that will give you the resultant. So the resultant will be 7.2 meter per second. So this will be this is how you do it with the calculation. Then their question is, what is the angle this resultant velocity will be making with the north? So basically, they are asking you to find out this angle. So this angle, let me take out the pen. So basically, they are asking me to find out this angle. So let me call this angle theta. So I will apply tan theta is equals to the perpendicular by the base, that's 6.8 divided by 2.4. So I will take its tan inverse and I will get 70.55 degree, which is approximately 71 degree. So this is the first method with which you can find the resultant and the angle the resultant will be making with the north. That will be 71 degree. The method number 2 is the graphical method. In the graphical method, what we do, we represent, we choose a scale. For example, I choose that 1 centimeter will be representing 1 meter per second. So the velocity towards the north, I will represent it with a arrow of 2.4 centimeter. And the velocity 6.8 meter per second will be represented with the vector with an arrow which is 6.8 centimeter, and it will be towards the east. So I have put both the vectors in such a way that their tails are joined together. When you put the vectors, two vectors whose resultant is to be found in such a way that their tails are joined together, then by completing the parallelogram, we can find the resultant. So what I will do, I will take a compass and I will open that compass 2.4 centimeter. I will take this point as the center and I will draw this line of the radius 2.4 centimeter. Then I will open my compass 6.8 centimeter. I will take this point as center and I will draw this arc, which is of the radius 6.8. Where these two arcs intersect each other, I will join that point with this point and this point with this point. So you can see the parallelogram will be completed. Then where the tails of the two vectors were joined, I will join it with the opposite corner of the parallelogram, and that will be the resultant of these two vectors. I measured that, and that was 7.2 centimeter. That means that because 1 centimeter was representing 1 meter per second, so that means that the resultant force, resultant velocity is 7.2 meter per second, 7.2 meter per second. Okay, then I will measure this angle. I will measure this angle. So this angle I will actually measure with the help of a protractor, and I found it to be 71 degree. So in my answer space, I will write the velocity is 7.2 meter per second at 71 degree from due north. I hope you understand. Let me reduce the size so you can see the whole question. Hopefully you understand this. This is the marking scheme of that whole question. You can pause the video, take your time if you want more time with this question. Question number 2, a spacecraft of the mass 300 kg. So the total mass of the spacecraft is 300 kg, is moving in a straight line in space at a speed of 8,000 meter per second. Calculate the momentum of the spacecraft. You see, if you want to find out the momentum is the product of the mass and the velocity. Mass must be in the kg and the velocity must be in meter per second. So I have done this. So very easily you can calculate the momentum of that spacecraft. So P will be equals to mv. So 300 kg multiply 8,000 meter per second. You will get 2.4 x plus 6 kg meter per second. So 2.4 x plus 6 kg meter per second. This is how this is done. Question number 2 and its B part, he says the fuel on the spacecraft explodes. The fuel has exploded. The fuel on the spacecraft explodes and the spacecraft splits into two parts. The direction in which the parts move does not change. So the direction has not changed. After the explosion, the speed of the front part increases, the front part, okay, and to 9,000 meter per second. It has a mass of 150 kg. Calculate the mass of the speed, calculate the speed of the rear part after the explosion. So there was a front part, there was a rear part, and when they were together, they were going at a speed of 8,000 and their total mass was 300 kg. Now, a fuel explosion has taken place and the spacecraft is no more in a one piece. Now it has two pieces. The front part is of 150 kg. That means the rear part is also of 150 kg because the total mass was 300 kg. And still they both the parts are moving in the same direction. The front part is moving at 9,000 meter per second. Now their question is, what is the speed of the rear part? Okay, you see the momentum before that explosion and momentum after that explosion is supposed to be the same. So now what will happen? The momentum before the explosion and momentum after the explosion will be same. So the front part mass multiply the velocity of the front part plus rear part's mass multiply the velocity of the rear part will be equals to the momentum which was before the explosion. And this is 300 kg and this is 8,000 meter per second. And that momentum was 2.4x per 6 kg meter per second. Now, the front part's mass is 150, its speed is 9,000. Rear part, its mass is 150. We don't know how much is its speed, and that will be equals to, so this equation. Then when you multiply 150 with the 9,000, you get 135,000. No, this is more than that. 135,000 plus 150, and U2 is the velocity of that rear part, and that is equals to 400,000. You bring this term here, you subtract it, you get 105,000. So divided with 150, you get 7,000. So the speed of the rear part is 7,000 meter per second. It's a very important numerical on the topic of the momentum because this topic is new in the Cambridge O-level syllabus, and we have very few questions on this topic in the Cambridge. We have questions, but those questions are in the IGCSE physics. And these questions are very, very important. Okay. So I hope you understand. Let's check the marking scheme. So our answer is right. This answer is also right. So this is the solution of the question number 2B, first part. Then he says the total kinetic energy of the two parts after the explosion is greater than the original kinetic energy of the spacecraft. State the energy transfer that occurs in the explosion. You see, when the explosion happened, actually the fuel exploded. The energy in the fuel is chemical potential energy. So that chemical potential energy would have converted into the thermal energy, and then it would have converted into the kinetic energy. So due to that, the fuel has chemical potential energy that converted into heat and then into the kinetic energy of the parts of the rocket. So this is my answer. This is the marking scheme. You can see this is our answers. Okay. Then he says the explosion lasts for 0.20 seconds. Calculate the average force on the front part during this time. Okay, so you remember if you want to find out the force, there are some formulae, and one very famous formula from the momentum is that the force is equals to the change in the momentum divided by time. Change in the momentum divided by time. So I will take the front part's momentum before the collision and after the collision, then I will find out the difference between its momentum, and then I will divide it with the time taken for that change of momentum, and that will give me, from then I can calculate the force which is applied on that front part. The momentum before the explosion of the front part, its mass is 150 and its velocity is 8,000. So you multiply 150 with 8,000, you get 120,000 kg meter per second. The momentum after the explosion of the front part is 1 mass multiply velocity. 150 multiply 9,000. Its velocity after the explosion is 9,000. So you get 135,000 4 zeros kg meter per second. Now, if you want to find the force is the rate of the change of the momentum. So it's the P2 minus P1 divided by T. So it is 1350000 minus 1200000, and you get its answer, and then you divide it with the time, which is 0.2 seconds, and you get 7.5 expo 5 Newton. 7.5 expo 5 Newton. 7.5 expo 5 Newton is the right answer, sir. This is how you do this numerical. Okay, so we have question number 3. He says a plain irregular lamina has a mass of 50 grams. It hangs from a nail that passes through a small hole H near to the edge of the lamina. The nail acts as a pivot and the lamina can swing about it. The lamina is held in the position shown in the figure 3.1, a small distance above a horizontal bench. Okay, so here you have that lamina, and let me tell you something. So center of gravity is this, and this is the pivot, the nail, and this is the line of the action of the weight. And you can see the perpendicular distance between the line of action of the weight and the pivot is 8 centimeter. So this is the moment arm. This weight will produce a moment, or you call it turning effect, due to the weight of this lamina, and that will be clockwise. And you can find that moment by multiplying the weight of this lamina with this moment arm, which is 8 centimeter. Moment arm is the perpendicular distance between the line of action of the force and the pivot, and that here is 8 centimeter. So he says the center of gravity of the lamina is at G. The weight of the lamina is a force that acts downwards. Explain why the lamina experiences this downward force. You see, lamina has mass and it is in the gravitational field of the Earth. So it experiences the gravitational pull or gravitational attraction of the Earth, and that causes its weight. Let me read you my answer. Lamina is in the gravitational field of Earth, so it is experiencing gravitational attraction of the Earth. So here you have the question number 3, and it's a part first portion. You can see the marking scheme. Okay, now next question number 3, part A, second portion. Calculate the weight of the lamina on the Earth. You know the weight, and we know the mass of the lamina, so very easily we can calculate the weight of the lamina. The weight of the lamina can be calculated by using the formula W is equals to mg. The G value is the gravitational field strength, whose value in this paper we take as 9.8 Newton per kg. And the mass of the lamina is given, and the mass of the lamina is given here, and it is 50 gram. But in that formula, the mass should be taken in kg, so I will convert that into kg, and the gram I will convert into kg. So if you want to convert 50 gram into kg, you will have to divide it with the 1000. So 50 divided by 1000 multiply 9.8, and that will be 0.49 Newton. 0.49 Newton is the right answer, sir. This is the solution. Okay, so question number 3, B part is first portion. The weight produces a moment about the pivot through H. Using the figure 3.1, calculate the moment of the weight about the pivot. So we now know the weight of the lamina, and that weight will produce a clockwise moment about the nail, which was at the point H. And the moment is equal to the force multiplied the moment arm. The moment arm here is the perpendicular distance between the line of action of the weight and the pivot, and that distance is 8 centimeter. But when we will put that moment arm into that formula, force multiplied the moment arm, and the unit must be meter. Why I know, how I know it should be meter? You can look at here. Here, the unit of the distance is meter. So very simple. The moment is equal to the weight multiply the moment arm. So it will be 0.49 multiply 8 and divided by 100. I'm converting it. Why I'm dividing with the 100? I'm converting it into the meters. So my answer will be 0.0392 Newton meter. 0.0392 Newton meter. The answer is right. This is the solution. And here we go. He says, the lamina is now released from the position shown in the figure 3.1. Describe what happens to the lamina from the time it is released until it stops moving. You see, when you will release this lamina, so this, the weight which is acting here, the weight is acting here, and this is the point pivot. So what will happen? This will produce a clockwise moment about this pivot. So this lamina will start swinging. So, and it will swing, it will swing, it will swing. And then gradually what will happen as it will be swinging, with every swing, the amplitude of its swing will gradually decrease. And eventually what will happen, the lamina will stop swinging. And when it will stop, the the center of the gravity of this lamina will be exactly below this point H where you have that pivot. I hope you understand this. Okay, so let me read my answer. So due to weight of the lamina, clockwise moment about the nail that is produced. Because center of gravity is lower than the pivot, lamina will swing about pivot. Amplitude of swing will decrease gradually and the lamina will come to rest in a position where center of its gravity will be exactly below the nail. I hope you understand. So you can see here the marking scheme is showing up. You can read these answers, pause this video, and you will have more time to look at this marking scheme. This is my written answer. Okay, so we are done with the question number 3. Now we are going to question number 4. He says, figure 4.1, this figure shows a long vertical tube sealed at the base and open at the other end. So this tube is sealed here and it is open on this end and it is filled with a dense liquid. The tube is 1 meter long. The cross-sectional area of the tube is 4 expo minus 4 meters square. It is filled with a liquid of the density 1.4 expo 4 kg per meter cube. So you can see this tube, it's 1 meter long, it's sealed here, this end is open, it's filled with the dense liquid. The area of the base is also given. The atmospheric pressure is 1 expo 5 Pascal. Calculate the total pressure in the liquid at the bottom of the tube. So basically they are asking us to find out the total pressure exerted here at this point. So the pressure here is the pressure due to this liquid above the point of observation, and plus here the atmospheric pressure is also acting. So the total pressure will be equals to the pressure due to the liquid plus the pressure due to the atmosphere. And the pressure due to the liquid, you remember the formula, the pressure of the liquid is rho GH, where the rho stands for the density of the liquid, G stands for the gravitational field strength there, and the H stands the depth of the liquid above the point of observation. So I will write the formula here. Total pressure is equal to the pressure of the liquid plus the atmospheric pressure. The pressure of the liquid is rho GH plus the atmospheric pressure. The rho, the density of the liquid, that is 1.4 expo 4. The G value is 9.8, and the height of the liquid, we call it actually the depth of the liquid above the point of observation, and that is 1 meter. Plus the atmospheric pressure is 1.0 expo 5 Pascal. So when you enter these values into your calculator, you will get 2.4 expo 5 Pascal. 2.4 expo 5 Pascal is the right answer, sir. This is my answer, my solution. Okay, the question number 4, and it's A, and it's the second part. He says, calculate the force exerted on the inside surface of the bottom of the tube. So if you want to calculate, you know the total pressure there, and if you want to calculate the force exerted at the base of that tube, so very simple, you know the pressure is equals to force by area. So the force will be equal to the pressure multiply area. So you can see here the pressure is equal to force divided by area. So force will be equal to the pressure multiply the cross-sectional area. So force will be equal to the pressure is 2.4 expo 5 Pascal. That's the total pressure at that point. And multiply the cross-sectional area there is 4 expo minus 4 meters square. So just multiply them on your calculator. You will get 96 Newton. 96 Newton. 96 Newton is the right answer, sir. This is how I have done this numerical. Hopefully you understand. Okay, so then we have question number 4, and it's B part. He says a small sheet of glass is placed over the open end of the tube. The tube is inverted in a container of the dense liquid. The open end of the tube and the sheet of the glass are a short distance below the surface of the liquid. Figure 4.2 shows the arrangement. This is the exact arrangement of a simple barometer. And you can see this container also has that dense liquid. And this is that tube. This is its open end. So the sheet of the glass seals the open end of the inverted tube. Describe what happens in the inverted tube when the sheet of glass is removed. So what will happen when you will remove this sheet of the glass? So this liquid which is in this inverted tube, the pressure of this liquid at this point will be more than the pressure, the atmospheric pressure. So this liquid will start coming out of this inverted tube. So the level of the liquid in the inverted tube will drop. And at some height, that drop and that level of the mercury will become steady. So when the level of the mercury becomes steady, that means the pressure of that liquid at this point has become equal to the atmospheric pressure. I hope you understand. Okay, level of the liquid will drop in the tube and will stop at some height. Level of liquid stops dropping when the pressure of the liquid at the bottom of the tube becomes equal to the atmospheric pressure. Initially, the pressure of the liquid at the bottom of the tube was greater than the atmospheric pressure. And then that dropped, and when it becomes equals to the atmospheric pressure, it do not further, the level of the liquid do not further drop in the inverted tube. I hope you understand these wordings and you have got the idea why this is happening. So this is the marking scheme. This is my answer. Okay. So we are going to the next question. He says, this equipment is used to make a measurement that is used to calculate the atmospheric pressure. Describe the measurement made and then used in the calculation of atmospheric pressure. You may draw a diagram to help your description. It's a 2 marks question, and this is the question. So basically, they are asking that what might you measure in a barometer. Okay, so here you see I have made that diagram. This is the level of the mercury dense liquid surface in the container. This is the level of the dense liquid in the inverted tube. So you measure the height of this level relative to the top surface level of that dense liquid in the container. So you measure this height. Then you apply this formula rho GH and you can calculate the pressure. Okay, so let me show you my answer. So measure the height of the liquid level in tube relative to the surface level of liquid in container. The atmospheric pressure will be equal to the rho GH, where the rho is the density of that dense liquid, G is the gravitational field strength, and H is the height of the liquid level in tube from the surface level of the liquid in container. So this is my answer. I hope you are able to understand what I am saying. So this is its marking scheme. You can pause the video. I don't need to read it. If you want to read this, it's very important to compare your answers with the marking scheme, or you check your answers from the marking scheme. You can take your time and read this marking scheme. So this is my answer. So we are on the question number 5. Figure 5.1 shows a device that cools the air in a room by evaporation. So here you have a water container. From this water container, water is dripping on this sponge, and the sponge becomes wet. And here you have a grill, here you have a fan, here you have a grill. So due to this fan, the air will be forced to pass through this sponge, and that air will be cold. That is like air coolers which we use in Pakistan and India. He says the water drips from the container into the sponge block and keeps it wet. Air flows in through one grill and out through the other. As the air flows through the wet sponge block, the water in the sponge block evaporates. When the water evaporates, the temperature of the water remaining in the sponge block decreases. Explain in terms of the movement of the particles why this decrease in the temperature occurs. You see, the water particles or the water molecules which have higher kinetic energy, they overcome the intermolecular forces, or you don't need to write this here. So the molecules with the higher kinetic energy, they come to the surface, and from there they evaporate. So the water molecules which are left in the sponge, they have less kinetic energy. So due to that, the water which remained in the sponge, its molecules average kinetic energy decreases. So that's why the temperature of that water in the sponge decreases. I hope you understand. Let me show you my written answer. I have tried to write this answer. So here we go. Water particles with higher kinetic energy evaporate from the surface of the sponge, leaving behind those water particles who have lesser kinetic energy. So the liquid left in the sponge has less average kinetic energy. Due to less kinetic energy, the temperature of the liquid in the sponge decreases. I hope you understand. Question number 5. This is the marking scheme of the. So you can take your time. This is my answer. Okay. He says question number 5, and it's A, and it's question number 5A, and its second part. He says explain why energy is needed when the water evaporates. You see, whenever the water evaporates, it needs to overcome the intermolecular forces. Its intermolecular forces with its neighboring water molecules or water particles. It has to overcome them, and plus it also has to overcome the force exerted on the surface due to the liquid due to the atmospheric pressure. So I think the reason is the water particles need energy to overcome the intermolecular forces between the water particles and to overcome the force due to the atmospheric pressure. So that was the question number, and you have to move the particles away from each other. Okay. So let's say he says question number 5, B part, he says state 2 ways in which evaporation differs from the boiling. You see, in the evaporation, the temperature of the liquid changes. And in the boiling, the temperature of the liquid remains constant. The evaporation occurs from the surface of the liquid, while the boiling occurs throughout the body of the liquid. So these are the two differences which just came into my mind. I've written during evaporation, temperature drops, but during boiling, temperature remains constant. We are talking about the temperature of the liquid. Evaporation occurs at the surface of liquid, while the boiling occurs throughout the body of the liquid. So these are the two differences, and there are other differences also. We just mentioned these two differences. You can write other differences. This question is very, very famous, the difference between the evaporation and the boiling. Okay, so we are going to the next question. That is question number 6. The loudspeaker shown in the figure 6.1 produces the sound of the frequency 800 hertz. So here we have a power supply. Here we have a loudspeaker. This is the cone of that loudspeaker. This vibrates forward, backward about its mean position. And the sound of the frequency 800 hertz is produced. He says state, A part is state what is meant by the frequency. The frequency means the number of complete waves passing from a point in 1 second. Or you can say the number of waves passing through a point in unit time. So number of waves passing from a point in a unit time. So this is the definition. Question number 6, A part. Question number 6, B part, he says explain whether the sound produced by the speaker is audible to a human with healthy hearing. You see, the sound which they are talking about is 800 hertz. The audible frequency range for a human ear is 20 hertz to 20,000 hertz. 800 hertz is in that range. So the human will be able to hear this sound because it belongs from that audible frequency range. So my written answer is the audible frequency range is from 20 hertz to 20,000 hertz. So a sound of 800 hertz is audible to human. Okay, so this is my answer. So question number 6, and then we have it's a C part, and he said describe the motion of the cone in the figure 6.1 and explain how this causes the production of the sound. You see, the cone of that loudspeaker will be vibrating to and fro about its mean position, and when it will move in the forward direction about its mean position, it will produce compressions in the adjacent layer of the air. The air particles will come closer to each other. The pressure of the air will increase. When the cone will go backward about its mean position, this cone motion will produce rarefaction in the adjacent layers of the air. So the air particles will move away from each other, the air pressure will drop. In this way, when this motion of the cone continues, it continuously vibrate forward, backward about its mean position. So continuously compressions and rarefactions are produced in the adjacent layers of the air. And in this way, the compressions, rarefactions are produced in the air, and a longitudinal wave is produced in the air, and the sound waves are produced. I hope you understand this. Okay, so the cone, here he says the cone vibrate forward and backward about its mean position. When it moves forward about its mean position, it produces compression in adjacent layers of air. When cone moves backward about its mean position, it produces rarefaction in adjacent layers of air. Thus, longitudinal wave, or you can say the sound wave, is produced in the air. So question number 6, C part, this is the marking scheme. And if you want to read it, you can read it. And hopefully you understand. I hope you can write a better answer. Okay, so question number 6, and it's D part. He says the sun is a very large and extremely violent ball of gas. Electromagnetic radiation from the explosions on the surface of the sun reaches the earth. Explain why the sound from explosions on the surface of the sun does not reach the earth. You see, the thing is very simple. The sound waves are mechanical waves. They require medium for their propagation. And between the sun and the earth, we have vacuum. So there is no medium available for those sound waves to travel from sun to the earth. So we cannot hear those explosions. Question number 6, D part, its answer, which I wrote. Sound waves are mechanical waves. They require medium for their propagation. There is vacuum between the sun and the earth. So the sound waves cannot reach from the sun to the earth. That's why we cannot hear those explosions. Okay, question number 7 on your screen. An electric circuit contains a battery, a fixed resistor R, a voltmeter, and a thermistor. Figure 7.1 is an incomplete circuit diagram of the arrangement. So their first question is the thermistor is connected between the terminals T1 and T2. Complete the figure 7.1 by drawing the circuit symbol for a thermistor connected between T1 and T2. So what I will do, I will draw a thermistor. So this is the symbol for the thermistor. We draw a symbol of the fixed resistor, and then we draw this ice hockey. This is basically the symbol of the thermistor. Okay, then he says the resistance of R is 2.5 ohm. The reading on the voltmeter is 0.40 volt. Calculate the current in the R. So the resistance of this is 2.5 ohm. The voltage drop across this R is 0.40 volt. How much is current flowing through it? We will use the Ohm's law. And you know the Ohm's law V is equals to, the V is equals to IR. So if you want to find out the value of the I, so that will be equals to V divided by R. So V divided by R, and the voltage value is 0.40 volt and the R value is 2.5 ohm. Just divide on your calculator 0.40 divided by 2.5 and you will get 0.16 ampere. 0.16 ampere. 0.16 ampere, and this symbol you can also see our answer is right. So this is my answer. I hope you understand. Then the question is the power transferred in the R. I know the voltage drop across the R. I know the current flowing through the R. So I can calculate the power. The electric power is equals to IV. Here the I value is 0.16 ampere and the V value is 0.40 volt. Just multiply them, you will get 0.064 watt. 0.064 watt. That is the right answer, sir. Okay, so the C part of the question number 7 is the temperature of the thermistor increases. Explain what happens to the reading on the voltmeter. So basically they are telling you that the here you have that thermistor. If the temperature of this thermistor will increase, the resistance of this thermistor will decrease. Then the current coming from the battery will increase because the resistance of this whole circuit will decrease. And because this resistance is fixed, it has not changed, and so the current flowing through it has increased, so the voltage drop here will increase. So here a larger voltage reading will be shown. So let me show you my answer and let me read it. When the temperature of the thermistor increases, resistance of thermistor decreases, R equivalent of the circuit decreases, current from battery increases. The resistance of the fixed resistor is unchanged, but current through it has increased. So the voltage drop across the fixed resistor increases. Hopefully you understand. This is their marking scheme is saying this. You can read this. It's very important to read the marking scheme. Very, very, very important. So we are done with the question 7. Now we are going on to the question number 8. He says figure 8.1 shows a permanent magnet attached to one end of an unstretched spring and held at rest just above a solenoid. So here we have a spring, here we have a permanent magnet, here we have a solenoid. This solenoid is connected with an ammeter. So he says the solenoid is connected to a sensitive ammeter, and then he says, state the name of a substance from which the permanent magnet are made. The very famous material from which the permanent magnets are made is steel. And in the B part, he says the magnet is released and moves downward towards the solenoid. The ammeter shows that there is a current in the solenoid when the magnet moves. 3 marks question. He says, explain why there is a current in the solenoid. You see, when this magnet will move toward this upper end of this solenoid, so its magnetic lines passing through this coil, they will change. Here, the less number of magnetic lines are passing through this coil. When this will come closer, more and more number of the magnetic lines will start passing through this solenoid. So when this permanent magnet will move towards the solenoid, the magnetic lines of this permanent magnet passing through that solenoid will change. And due to this changing magnetic lines passing through that solenoid, EMF will be induced. EMF will be induced and the ammeter will show reading. So for permanent magnet, we use steel. When the permanent magnet moves downward relative to the solenoid, the magnetic flux passing through the solenoid changes. This induces EMF in the solenoid. We call it Faraday law of electromagnetic induction. You can read this marking scheme. This is my answer. Okay, so we are going to the next. We are done with this B part. Now we are going to this B second part. He says the current causes the top end of the solenoid to become the south pole of an electromagnet. The bottom end of the permanent magnet is a south pole. Explain why the top end of the solenoid becomes an S pole as the magnet moves downward towards the solenoid. You see, when this is going down, so the south pole is approaching the top end of this solenoid. So the EMF induced, this is Lenz's law. Lenz law. Okay. So the EMF induced in the solenoid, EMF is induced in the solenoid due to this motion. Its direction will be such that it will try to oppose this approaching south. To stop this approaching south towards the top of this solenoid, a south pole will be induced due to electromagnet on the solenoid. That is Lenz's law. Lenz's law says that the EMF induced in that solenoid, its direction will be such that it will try to oppose the cause which is inducing that EMF. So to stop the motion, to oppose the motion of that south pole coming near the top end of the solenoid, the top end of the solenoid will become a south pole to stop that south pole. The electromagnet formed on the solenoid due to induced current in the solenoid will have south pole on the top to oppose the approaching south pole of permanent magnet. This is according to the Lenz law. He says mention the Lenz's law. You can mention the Lenz law. Lenz law is that the induced EMF, the direction of the induced EMF in the electromagnetic induction is such that it opposes the cause which is producing that EMF. I have not written that here. You can write that also. Okay, here we have the C part of this question. He says the magnet oscillates up and down. Describe what happens to the current in the solenoid. So when this magnet will vibrate, comes down, goes up, comes down. So when it will come down, the EMF induced will have a certain direction. When it will go back, because it is vibrating, so the EMF induced will have an opposite direction. So when it is moving, that permanent magnet is moving up and down relative to the solenoid, the EMF induced in the solenoid will be alternating current. And the magnitude and the direction of that alternating current will be periodically changing. An alternating current will be due to up and down motion of permanent magnet, current induced in the solenoid will be alternating current. magnitude and direction, and the direction of induced current changes periodically. I hope you understand. So that was question number, I think, 8. Now we are on the question number 9. He says, in space, an interstellar cloud of dust and gas collapses to form a protostar. The cloud contains hydrogen. Describe the energy transfer that takes place as the cloud collapses and forms the protostar. You see, when there is a cloud of dust and gases, and more cloud and dust is accumulating there, so the gravitational attraction increases in that cloud of dust and gas. So when the gravitational attraction increases, these particles and that the cloud of dust and gas density increases, and due to that, the kinetic energy of that dust and gas cloud also increases. The particles will have higher kinetic energy. So due to that, its temperature increases. Due to very strong gravitational attraction, cloud of dust and gas collapses, so its gravitational potential energy converts into kinetic energy. Temperature of the cloud of dust and gas increases. When the temperature increases, obviously the kinetic energy and the internal energy of the star or protostar increases. Hopefully you understand what I'm saying. This is the marking scheme. This is my written answer. Then he says in the question number 9, it's B part, the collapse results in a nuclear reaction in the protostar that involves the isotope hydrogen 3, which is hydrogen 1, 3. The isotope hydrogen 3 is radioactive. It decays by beta particle emission. State how the nuclei of isotope of the same element are different. That is the question, B first part. You see, the isotopes of the same element have their nucleon number is different from each other. They have different number of neutrons in their nucleus. Their number of protons is same, but their number of neutrons are different. That's why their nucleon number is also different. 1 mark question. Nuclei of isotope of the same element have different number of neutrons in their nuclei. So they have different nucleon numbers. So this is the marking scheme. This is my answer. So B second part is, he says, explain why hydrogen 3 cannot decay by alpha particle emission. You know, the alpha particle is like the nucleus of helium, and nucleus of helium has 2 protons and 2 neutrons. Its proton number is 1, its proton number is 2, and its nucleon number is 4. But this hydrogen 1, 3 has only 1 proton. It has only 1 proton. So it cannot give out alpha particle, because alpha particle have 2 protons and its nucleon number is 4. Nucleus of hydrogen 1, 3 has only 1 proton. Alpha particles have 2 protons and 2 neutrons. So they cannot be emitted from the hydrogen 1, 3. Hopefully you understand what I'm saying. Okay, then he says complete the equation for the decay of the hydrogen 3 to an isotope of helium. Okay, so here a beta particle is given out. You see here I've done that. Beta particle is proton number is -1, nucleon number is 0. The helium produced here will have 2 proton numbers. Its proton number will be 2 and its mass number will be 3, because this is 3 here, so that's why you will have 3 here. It's a little tricky question. Let me show you. You can see the marking scheme. Okay, the B fourth part, he says, explain how the nuclear reaction in the protostar stops further collapse as the protostar becomes a stable star. You see, there is an inward force in the protostar, which is due to the very strong gravitational pull of that dust cloud. And when the nuclear fission, and the temperature is very high in the protostar, so the nuclear fission, sorry, I said fission, nuclear fusion starts. In the nuclear fusion, the hydrogen and hydrogen fuse with each other and they produce helium. And when that process is happening, enormous amount of heat is produced. And due to that nuclear fusion, the heat is produced and it creates an outward force. So the gravitational pull is trying to collapse that star, and the energy produced due to the fusion, that energy produces an outward force. And when that inward force and that outward force are balanced with each other, we say the star is a stable star. Let me read my answer. Due to the further collapse in the protostar, temperature rises. This starts a nuclear fusion of hydrogen. Hydrogen converts into helium due to the fusion. And this nuclear reaction produces large amount of heat. This produces an outward force. Inward force due to gravity is balanced. So I have to write D, is balanced by the outward force. Star becomes a stable star. Okay, I hope you understand this answer. This is my written answer. Okay, then he says the C part is question number 9, C part. The cloud of dust and gas that collapses also contains atoms of the heaviest elements. State which part of the life cycle of a star is responsible for the production of the heaviest elements. You see, it's very simple. When all of the hydrogen has been used in the fusion, then the fusion of that you know uh, helium, then the fusion of the helium starts, and that happens. So then the helium fusion starts, which produces carbon, then the carbon fusion starts. So in this way the elements fuse with each other, and they produce heavier elements. And this happens when in the life cycle of the star, when the star is a super red giant, and then it explodes, supernova happens. It has at that moment the heaviest elements in its life cycle. When the supernova happens in the red supergiant star, fusion of heavier elements produces heavier elements, further heavier, more heavier. I should have written here more heavier elements. Okay, red supergiant explodes as supernova explosion. So these are the life cycles of of the star. Okay, just remember those stages of the life of the star. Okay, so we are on the question number 10. The isotope iodine-131 emits two types of nuclear radiation. Gamma radiation is one of the types emitted. Gamma radiation is electromagnetic and it do not have any charge on it. It's neutral. A sample of iodine-131 produces a narrow beam of radiation that passes into a magnetic field. Figure 10.1 shows some of the paths taken in the magnetic field by the radiation emitted from the sample. So you can see some of the radiation has bended downward to the bottom of the page. Some of the radiation has been unaffected. None of the radiation has bended towards the top of the page. The magnetic field here is into the page. The direction of the magnetic field is into the page, A part. On the figure 10.1, mark with the gamma symbol any of the paths taken by the gamma ray. So this line which went straight undeflected, that is basically gamma. Okay. Then he says, determine the other type of radiations emitted by the iodine 131. Explain how you obtain your answer. Type of radiation explanation. Okay. So let me try understand this. This is my left hand. Okay. So when you are looking, because it will appear that this is my right hand, but this is basically my left hand. Okay. So I'm going to apply the Fleming's left hand rule. So I will stretch my these three fingers. This is thumb, this is the index finger, and this is the middle finger. So I will stretch it. The magnetic field is into the page, and the charged particles are going towards the towards the right, and my thumb is pointing upward towards the top of the page. And the particles, the charged particles who obey this Fleming's left hand rule are positively charged. But none of the radiation bended upward. So that means they bended towards the bottom of the page. That means those charged particles which are bended towards the bottom of the page, they are going opposite. They have shown opposite deflection, which my thumb is pointing. That means those radiations have negative charge on them. So the radiation which has negative charge on them, that is called the beta particles, which are negatively charged and have electrons. They are like electrons, I mean. Type of radiation is beta. Explanation I have given to you. Let me read. I have written this. Okay. If we use Fleming's left-hand rule, charged particles are going to the right, magnetic field is into the page, thumb of the left hand points towards top of the page. But the particles banded to bottom of the page, so they are negatively charged and they are obviously beta particles. I hope you understand what I have written. You see, when you use your left hand and, let me show you. So when we use the left hand, this is my left hand. This is actually my left hand. So FMC, FMC. F is the force, and M stands for the magnetic field, and C stands for the charged particles, the direction of the charged particles, in which the charged particles are basically going. So when I stretch them, they are perpendicular. This is the thumb, this is the index finger, this is the middle finger. So this is how I used it. So hopefully you understand, and if you have some confusion with it, then you can see some video on the left hand rule. Then he says, in another experiment, the beam of radiation from the sample is incident on a 5 millimeter thick sheet of lead. State what happens to the two types of radiation in the beam. You see, the beta particles, their penetration power is less, so they will not be able to pass through this 5 millimeter thick sheet of lead. So the beta particles will be definitely completely absorbed by this sheet, and they will not be able to pass through this sheet. Whereas the gamma radiation, some of the radiation may be able to pass through it. So this is our answer. All of the beta particles will be absorbed by this lead sheet. Some of the gamma radiation may pass through 5 millimeter thick sheet of lead. This lead sheet is not that thick enough. Okay. So you can see the marking scheme. Okay, so the last part of due to the internet, there was a problem of the internet and my recording stopped. So the very last part of the question number 10 was left. The gamma is the B part of the question number 10 of the October-November 2023 2 paper. The gamma radiation produced has a frequency of 8.8 expo 19 hertz. The speed of the electromagnetic radiation in a vacuum is 3 expo 8 meter per second. Calculate the wavelength of this gamma radiation in a vacuum. You know, V is equals to F lambda. So the wavelength lambda is question. So very simple, V is equals to F lambda. Lambda will be equals to V by F. So the lambda will be equals to 3.0 expo 8 divided by 8.8 expo 19. Then the lambda will be 3.4 expo minus 12. 3.4 expo minus 12. 3.4 expo minus 12 is the answer, sir. So you can see this is the right answer. So by doing this, we have reached the end of this paper, which was October-November 2023 2 paper. If you find this video interesting and useful, please share the link of this video with your class fellows, with your junior students, and so they can also benefit from this video. Please like this video. Please share the link of this video on to your WhatsApp, onto your Facebook, onto your Twitter, onto your Instagram, because when you do this, this helps me to promote my channel. So I am really grateful to the God that He has given me the chance to make these videos, which can touch the life of so many students around the globe and make their life, their parents' life, their teachers' life little easier. So thank you very much. Have a good day. God bless you all.